and turn to page 21. Okay, today will be the last lecture on hydroxyl compound. Before I begin the lecture, here is an announcement. Okay, this Monday you can start to collect your hydroxyl tutorial from the photocopying shop. Okay, it costs about 10 cents per student. Okay, so please help to collect the tutorial. So at the back, would you like to share what's the joke over there? How come there was some smiles being exchanged? Yes, the one in orange. If you think you can tell a funnier joke than me, certainly you can take over my place. Okay, in the last lecture we looked at this new functional group which is known as phenol. Okay, the functional group of phenol, the structure is OH directly bonded to benzene ring. Okay, and one thing about phenol is that it is actually a weak acid. So in the last lecture I showed you guys that in experiment, okay, we use the universal indicator to find out what is the pH of phenol in water, and we realize that it is about pH 5 to 6, and hence it is a weak acid. Okay, so if it's a weak acid, this is how we represent the dissociation. Okay, and like what I mentioned, this will be the more accurate representation after you have learned chemical or ionic equilibrium. Okay, and of course we also obtain pKa values to indicate that carbonic acid is a stronger acid than phenol, which in turn is a stronger acid than water, and of course your alcohol, for example ethanol, is the least acidic. Okay? So for the Ka and pKa value, don't worry, okay, later on term 2 we'll come back to it again. So usually in questions, okay, this is how Ka and pKa is being applied. Like they will tell you, from experiment, the Ka or pKa value is as such. Can you explain why is there a difference in the acidity? Alright? So here, like what I mentioned, the definition of acid that we are going to use is that of the Bronsted-Lowry definition. So according to Bronsted-Lowry, okay, an acid is a proton donor. So after an acid donates or gives off a proton, you are left with an anion. So this anion, there's a special name for it. It is known as conjugate base. So a conjugate base, okay, if you want a more precise definition, it is actually a proton acceptor. Okay, so acid is a donor, then the conjugate base is the acceptor, which differs from the weak acid by one proton. So with this understanding in mind, okay, we look at why is it that phenol is more acidic than ethanol. So first and foremost, like what I mentioned, okay, if it comes out in a test or exam, the very first thing is you must show the acid dissociation equation. So what are the acid dissociation equation? Okay, the examples are given in your lecture notes. So the first one for ethanol and the second one for phenol. right? So now, okay, we explain by looking at the conjugate base. For phenol, after it gives away a proton, you have the phenoxide ion. And since O is directly bonded to benzene ring, okay, it means that the negative charge on phenoxide ion can be delocalized into the benzene ring. And this in turn will enhance the stability of the phenoxide ion, thus making the proton dissociation more favorable. On the other hand, okay, for ethanol, after it gives off 1H plus, you notice that the ethoxide ion, okay, the ethyl R group, okay, is electron donating. So this will intensify the negative charge on O, thus making it less stable than your phenoxide ion. And that is why, okay, phenol is a stronger acid than ethanol. And of course, we end off at this part. Okay, this part I tell you guys that prior to the lecture on phenol, the only acidic compound that you guys think of is your carboxylic acid, COOH. But after learning phenol, okay, you guys have to know that phenol is actually acidic as well. So in your structural elucidation question, if the question tells you, oh, this unknown is acidic, okay, you have to consider phenol. Okay, how do you exclude phenol at the end of the day? Very simple. If the question tells you that, hey, this compound does not liberate carbon dioxide when reacted with your sodium carbonate or sodium hydrogen carbonate, then you know it cannot be, then you know it has got to be phenol, right? If it cannot liberate. If it can liberate carbon dioxide, it means that it is carboxylic acid. So this part, like what I mentioned, for use in structural elucidation question. So now we are going to learn new things, okay? What are the factors that will affect the acidity of phenol? In this case, we will need to look at are there any substituents present on the benzene ring itself or not? So this part here is similar to what we have encountered previously under electrophilic substitution, where we look at the effect of substituent on the benzene ring. Okay? First and foremost, okay, let's say if your phenol has an electron withdrawing group, for example, Cl, Br, NO2, okay, what happens to the acidity? So you know that electron withdrawing group, they like to withdraw electron density towards itself. So in the case of the example as shown here, okay, what happens is that after the dissociation of proton, the electron withdrawing group is going to better disperse or decrease the intensity of negative charge on the O minus. Okay, because it is electron withdrawing, so it draws away any electron density towards itself. And as a result, okay, the phenoxide ion is more stabilized. And here, okay, this part here about equilibrium, position of equilibrium, don't worry. Term 2, we will learn about chemical equilibrium. Okay, so this part, if you don't understand for now, never mind. Keep in view in term 2, right? So what happens is that since this phenoxide ion is now more stabilized because of the negative charge dispersal, it means that the forward reaction, the proton dissociation, is more favorable, or you can say that there is a greater extent of acid dissociation. Therefore, acidity increases. Okay? This part okay? I hope you have copied down the words in green. Can? Okay, so this table over here, you don't have to memorize. All I need you guys to know is that from phenol, okay, now if you were to have electron withdrawing group on benzene ring, for example, your Cl, your NO2, you notice that the Ka value increases. Okay, the greater the Ka value, the stronger the acid will be. Correct? Alternatively, okay, if you are given pK pKa value instead. The smaller the pKa value, the stronger the acid. So the important thing here is, after looking at the given data, are you able to explain or not? That is the more important thing, explanation of the given data. So now, okay, instead of having electron withdrawing group on the benzene ring, if you were to change it to electron donating group, for example, your LQ group, what happens? So after acid dissociation, okay, the electron donating group will transfer electron density towards O minus. This will then intensify the negative charge, okay, making the phenoxide ion less stable. So when it is less stable, do you think the forward reaction is favorable? Yes, no? No, right? So if the forward reaction is not favorable, another way of saying it is that the equilibrium now shifts more towards the left. Okay, and as a result, you are going to get less of the product. And if you get less of the product, it means that you get less of the H plus. So at the end of the day, the conclusion is that the acidity is now lowered. Okay? Any difficulty with understanding these two parts? So the thing here is very important. Okay, don't confuse with what you have learned under Arins. Okay, the part on electrophilic substitution. So in electrophilic substitution, you know that when you have electron donating group, the rate of electrophilic substitution will increase, because the electron donating group, what does it do to the benzene ring? It increases the electron density of the benzene ring, thus making it more prone or more susceptible towards electrophilic sub. Okay, so the outcome is actually different, opposite in this case when we talk about acidity. When you have electron donating group, it is actually making it less acidic. Also, don't confuse, right? Yeah, I think it is important. This part tends to come out often in explanation-based questions. So right now, I'm going to give you a short exercise, okay, to consolidate your knowledge. So here I have with me 3 phenolic compounds. Okay, the task is very simple. Arrange the following compounds in order of increasing acidity, and of course, give your explanation. Okay, so right now, take about 5 minutes to do this exercise. Right, later on we'll go through the answer. Okay, since the question is rather short, if you want to quickly jot it down in your blank space on page 21, okay, page 21 underneath you have some blank space, so quickly jot it down. Okay, before I go through the answer, perhaps I would like to re-explain this part again. I think some of you are still trying to come to terms with the new concept. Okay, so for those who are still unsure of, let me try to re-explain it again. Okay, first thing first, I'm going to use electron withdrawing group. Okay, so now after acid dissociation, right? This is electron withdrawing group. So whatever electron density up here will be drawn. It will be drawn towards Cl via the benzene ring. Correct? So now if the electron density from O minus is being shifted towards Cl, it means that it is less susceptible towards protonation. That means it is O minus and H plus will not, the recombination of O minus and H plus will be disfavored. That's why it is a stronger acid. You understand? Okay? Here we are talking about acid dissociation. How readily can we form H plus? So if your O minus is more intensified, it will tend to go back into the neutral molecule, right? Correct? So the idea is, as long as you can make the intensity of the negative charge lesser, it will not want to go back to the neutral molecule. Therefore, it is a stronger acid. So if you can understand the electron withdrawing part, then for the electron donating part, it is the opposite. Okay, so here you have the electron donating group. So what happens is that here, okay, let me use a different color. So just now we see that the arrow is from O minus to Cl, right? So for electron donating, it is the opposite. Okay, so CH3 will donate electron density towards O minus via the benzene ring. It will intensify the negative charge. So originally it is like this, but with the presence of CH3, it becomes even greater, the charge intensity. So when the charge intensity is larger, okay, it tends to recombine with your H plus to form back the neutral molecule. That is why it is less acidic. You understand? Okay? So if you understand the explanation, we can look at the question. So in this case, the order of acidity is as such. Okay, the most acidic will be this, followed by 4-methyl phenol, and last but not least, 2-methyl phenol. So this is the order, 1 mark, stating the order. Okay, after you have stated the order, here comes the explanation. So here what happens is that 4-bromophenol is most acidic. Why? Because on the benzene ring, you have an electron withdrawing group in the form of Br. Okay, so it will disperse the intensity of the negative charge on the O minus of your phenoxide ion. Okay, thus making it more stable, and hence acid dissociation will be the greatest. Some of your chemistry teachers just went for a sharing session, and during the sharing session, it is stated that if you were to write down notes, you learn better. Okay, so whenever possible, try to write down notes instead of taking pictures. Because once you write down the content, in your mind, you are also processing like whether does it make sense or not. So in this way, you will learn better. Okay, so that is for your 4-bromophenol. So now we compare 2-methyl phenol and 4-methyl phenol. Okay, so why is 4-methyl phenol a stronger acid than 2-methyl phenol? It has got to do with the proximity of the methyl group. Okay, how near or how far it is from your O minus. So in this case, 2-methyl phenol is less acidic because in 2-methyl phenol, the methyl group is closer towards O minus. And what is the effect? The effect is that it will exert a greater electron withdrawing effect, which in turn further decrease the intensity of the negative charge. It should be increase. Further increase. Okay, further increase the intensity of the negative charge on O minus than in 4-nitrophenoxide. And what's the outcome? The outcome is 2-methyl-phenoxide will be less stable than your 4-methyl-phenoxide. Therefore, 2-methyl-phenol is a weaker acid than 4-methyl-phenol. So in this question, okay, the first part is nothing new. The first part talks about the comparison between electron withdrawing and electron donating group, okay, which we have just looked at in the lecture notes. The second part is something new. The second part talks about the proximity of the substituents on the benzene ring with respect to the O minus. Okay? Where? Which one? Oh, sorry, yeah. That's good. Okay, it goes to show that you are learning, right? So such a question probably about 3 to 4 marks in test or exam, alright? Okay, are we done with the copy? Yes. Okay, this part. Is everybody okay? Yeah. Last paragraph. Third paragraph. Okay, so this one, right? So which one I'm talking about? In, Yep, you are right. Okay, here what happens is that previously I didn't use methyl as a substituent. On the other hand, I actually used nitro as a substituent, but I think it may be a bit difficult. Okay, so I decided to scale down at the last moment. So that's why you notice that there are some inconsistencies. Okay, are we good with this? Alright. So now we'll look at the reactions involving phenol. Okay? There are only 2 reaction sites that you can have in benzene ring. So when we talk about benzene ring, please remember your electrophilic substitution. It is what you have learned before, just that there is slight changes, right? Later on we'll see. So first and foremost, okay, reactions involving OH, okay. Phenol can react with your sodium metal. Okay, the reaction is the same as what you have seen in alcohol. So you are going to get a salt and hydrogen gas. What will be the type of reaction in this case? What will be the type of reaction in this case? Start with R. Redox, right? Not reduction, but rather redox, right? Okay, this part is what I mentioned yesterday. This is the difference between phenol and alcohol. Phenol is a weak acid, whereas alcohol, you can say it is almost neutral. Therefore, okay, phenol will react with your aqueous sodium hydroxide to form the salt and water, but not your alcohol. The type of reaction in this case is actually your neutralization reaction, okay, which you have seen before in O level, nothing new. So here we have a note. Let's say by mistake you add in the sodium hydroxide and you regret. So how can you get back phenol from phenoxide? The answer is very simple. Okay? You just need to add any inorganic acid such as HCl, HNO3, okay, maybe not HNO3, okay, maybe not HNO3. Probably the best will be HCl, okay? Why not HNO3 later on we'll see, okay? So HCl being a stronger acid than phenol, okay, it will force phenol to become the neutral molecule instead of being dissociated. So this is the equation, right? So if you want to get phenol from your phenoxide ion, very simple, just add in acid. Next, here, okay, there's one important thing that I need to address is that yes, phenol, okay, it does not react with carboxylic acid to form ester. Here, okay, some of you may be thinking, oh, is it because phenol is acidic? Carboxylic acid is also acidic. That's why acid and acid don't react. The answer is wrong. Okay, this is not the correct reasoning. So write it down. Okay, this is not the correct reasoning. Write this part down, please. Okay, write it down. Put a big cross beside to tell yourself that this is not the correct reasoning. I'll show you the correct reasoning after you are done. Okay, so the reason why phenol does not react with carboxylic acid to form ester is because, okay, the type of reaction for esterification is that of nucleophilic substitution. So here, what happens is that OH minus, okay, is a poor leaving group. So the carboxylic acid, the OH on carboxylic acid does not want to come out as OH minus. And more importantly, on the phenol itself, okay, on O, you have the lone pair of electron, but this lone pair of electron tends to delocalize into the benzene ring. Okay, and as a result, it is not readily available for nucleophilic sub with your carboxylic acid. That is why. So previously in alcohol, okay, we learned that esterification is a slow and reversible process. So to counter this problem, we use a more reactive reagent in the form of acid chloride. Similarly, we are going to use this approach in order to get ester from your phenol. Just react phenol with acid chloride at room temperature. Okay? Are you all done with the copying? after today's lecture, please do not tell your tutor that phenol and carboxylic acid do not react because both are acidic. That is a big mistake, right? Alright, so like what I mentioned, if you want ester from phenol, very simple, you react phenol with acid chloride at room temperature. If you want a better effect, a better outcome, okay, you can do the following. You can react phenol with your sodium hydroxide first to obtain phenoxide ion. Phenoxide ion negatively charged, it is a stronger nucleophile and hence can better react with your acid chloride. So either way, if you want, you can react phenol with acid chloride at room temperature. If not, okay, first step, you deprotonate phenol first to form phenoxide ion, followed by the reaction with acid chloride at room temperature. Okay, so in test or exam, if you're asked for the reagents and condition, either or, right? So just now I mentioned, okay, there are only two sides, so we have looked at reactions involving the OH group. Now, we look at the reactions involving benzene. Essentially, okay, recall what you have learned under electrophilic substitution. So, in one of the tutorial questions in Arins, okay, you learn about phenol, okay, the OH group making the benzene ring more reactive towards electrophilic sub. So the reason is as given here again. Okay, why does the OH group make the benzene ring in phenol undergo electrophilic substitution more readily? It's because the lone pair of electron on O can be delocalized to the benzene ring, which increases the electron density of the benzene ring towards which increase the electron density of the benzene ring, thus making it more susceptible towards electrophilic substitution. Okay? And when it is more susceptible towards electrophilic substitution, do you still need to use a harsher or do you need to use a milder reaction condition? Milder, right? Sensible, right? Milder. So in this case, okay, we will see the extent, okay, how mild can we go when we have phenol. So here I will copy down the words in green. Okay, so remember, OH group is ring activating, it is 2,4 directing. So in the context of nitration, okay, previously when you had benzene, the reagents and conditions are what? Corn H2SO4, corn HNO3, what's the temperature? 55 degrees Celsius, right? Correct? Okay, so what's the purpose of using corn H2SO4? Catalyst to generate a strong electrophile, NO2+. But in the case of phenol, you realize that, number one, there is no need for corn H2SO4 acid catalyst. Why? Because here, due to the ring activating property of OH group, okay, phenol will undergo electrophilic substitution more readily, and hence you don't need a stronger electrophile. So in this case, okay, just dilute nitric acid at room temperature will do. So the reagents and conditions here, dilute nitric acid, room temperature, full stop. Okay? After the reaction, you are going to get a mixture of product. So here, take note that it is N, not all. Both 2-nitrophenol and 4-nitrophenol will be produced. Okay? Which means to say that if you just want 2-nitrophenol, you got to do purification. And for those of you who are interested to know the appearance, okay, they are essentially yellow color in the solid form. Okay, both 2 and 4-nitrophenol, they are yellow color in the solid form. Okay? So here the important thing is to take note, you don't need a harsher reagents and conditions anymore. You can use dilute at room temperature. So here what happens when you forget and you use corn nitric acid? You're going to get multiple substitution. Okay, the product that you obtain is actually 2,4,6 trinitrophenol, not your trinitro-tro-lolo. Alright? So your 2,4,6 trinitrophenol, okay, it is an explosive. Right? Yeah, very funny. Okay, the important thing here, the difference is concentration. Previously, you use dilute, now you use concentrated. When you use concentrated, you get multiple substitution. So this is how 2,4,6 trinitrophenol looks like. Okay? And this is the balance equation. Right, this is your balance equation. So in the case of halogenation, same thing. Okay? Previously in benzene, Previously in benzene, okay, it requires the use of your halogen carrier, for example AlCl3 or FeBr3. But in the case of phenol, you don't need your halogen carrier. So when you don't need your halogen carrier, you can use aqueous medium. Because the aqueous medium will destroy the Lewis acid catalyst, your halogen carrier. But now you don't need, so you can use aqueous medium. So for example, okay, here, if you want mono-substituted product, okay, you can react benzene, which is dissolved in non-polar solvent like CCl4 at room temperature. Okay, so this is what happens. You get 2 bromophenol and 4 bromophenol. So same thing, a mixture of product is obtained. Okay, this part here is important because sometimes in distinguishing test, okay, especially you are asked to give the observation. So here the observation is that your reddish brown bromine is decolorized. Why reddish brown? Because bromine is dissolved in organic solvent. This part you have learned under alkene. And at the same time, because you have HBr, you are going to see steamy white fumes. Alright? Okay? So just now I mentioned about the use of aqueous medium. Yeah. So now when you use bromine water as the reactant, what happens? You are going to get multiple substituted product. Okay? So in this case, the observation, number 1, your bromine from orange red, it decolorizes. Number 2, you are going to get a white PPT, which is your 2,4,6 tribromophenol. Okay, this is your white PPT. And same as before, HBr, white steamy fume is evolved. And here, this is important because this is a distinguishing test for phenol, with the exception of phenylaniline. Okay, phenylalanine looks like this. We'll look at it later on under nitrogen compounds. Right? Okay, so I need you guys to write down this part except phenylaniline. Okay, both phenol and phenylaniline will give you the same observation, so you cannot distinguish between them. Okay. So other than this particular distinguishing test, okay, you can also, are you done? You can also use neutral FeCl3 aqueous, okay, to see whether this compound contains phenol or not. So the observation is that you will notice a violet coloration, okay, a purple color. So to better give you an idea how this purple color looks like, here I'm going to show you a video. Okay, so now this is your phenol. Okay, notice my cursor over here. This is your phenol. Okay, so now you have your neutral FeCl3 aqueous, and you notice the violet coloration, purple color, right? So here, what happens is that you don't need to know what is this purple color complex. This purple color thing, okay, is not required by the syllabus, so you don't have to care about the formula and structure. And some of you may ask, how come we use neutral? The usage of neutral condition is to prevent your acidic phenol from having side reaction at other pH. So this you may want to note it down. So saya tiba tak sipping duty beside you. Okay, so these are the two distinguishing tests for phenol. You can either use bromine water at room temperature, okay, and you see whether or not you have your white PVT, your white semi-film of HBr, and the decolorization of what color? What's the color of bromine? Brown. For bromine water, bromine aqueous, brown. Right, orange red, okay. Alternatively, you may want to use neutral FeCl3 aqueous, right, at room temperature as well. So now, this part is also important, okay. Previously under alcohol or even in RX, okay, we see that you can form RCl from alcohol using FOCl2 or PCl5 at room temperature, correct? So take note, okay, because of the delocalization of lone pair of electrons on O into the benzene ring, there will be partial double bond character, right, between the O and the C of benzene ring. So this prevents nucleophilic substitution. So that is the explanation in this case. Why phenol does not react with your PCl5 and SOCl2. Okay, it is related to nucleophilic sub. Right? So this part important, please. Common mistake made by students, they happily see the OH group, then they substitute with Cl. But that is not the case for phenol. So now, okay, let me do a quick summary of phenol. So like any other organic compound, phenol can be combusted, but in this case, because of the high carbon to hydrogen ratio, okay, the observation that you will notice is the presence of sooty flame. Okay, so this particular observation also applies to benzene, when you try to combust benzene. And then we know that phenol can react with your sodium metal to form sodium phenoxide and hydrogen gas. It is acidic, it is weakly acidic, it can react with sodium hydroxide to form sodium phenoxide and water, type of reaction, neutralization. For sodium carbonate, do you think there will be a reaction? Who say yes? Who say yes? The answer is no. Why? Because phenol is a weaker acid than your carbonic acid. So that's why there is no liberation of carbon dioxide in this case. And then phenol does not react with your carboxylic acid to form ester. Instead, okay, you need to use acid chloride, which is more reactive. So like what I mentioned before, you can react phenol with acid chloride at room temperature. If you want better effect, okay, you can first do deprotonation to obtain a stronger nucleophile in the form of phenoxide ion, followed by reaction with your acid chloride. So all these reactions, we can classify them under reaction at the OH group. So next, okay, the reaction can take place at the benzene ring, and that will be what we have learned under electrophilic substitution. If you were to do dilute nitric acid at room temperature, we are going to get a mixture of 2 and 4 nitrophenol. If you use concentrated HNO3, this part here, okay, sometimes in some textbooks or your friends from other schools, okay, they also put down con H2SO4, but in SA we just focus on con nitric acid at room temperature. You will get your explosive, right? The 2,4,6 trinitrophenol. And for bromine in CCl4, a mixture of product, okay? Bromine in aqueous, you will get your multiple substituted product. Okay, and last but not least, okay, your neutral aqueous FeCl3 as a distinguishing test as well for phenol. So that will be the end of the lecture on hydroxyl compounds. Okay, next Tuesday is your e-learning day. So now, Mr. will give you an important briefing. When I say the word important, I think it is good for you guys to pay attention.
JC2s, please listen now. If your friends are still sleeping, please poke them awake. I just spoke the guy awake just now. Alright, as Mr. Xiao has mentioned, your e-learning day is going to take place next Tuesday, 27 Jan. Good news, you don't have to come to school. Bad news, every subject you must do something. Yeah, too bad. Okay, so how is your e-learning going to take place? It's through Ask and Learn, so it's something that you're all familiar with. However, we're going to use a function that I don't think any one of you has used before, which is the forum function. Okay, Ask and Learn, log in is what you should know. Okay, so this forum, right, it will not appear yet. It will only appear when you access it on Tuesday. Okay, so now you go and see, right, don't have, I cannot find. So it will look something like this. So let's say your class is SO6, then you'll see a H2 Chemistry e-learning for SO6 example, okay, with your tutor's name there. So I know that some classes are split classes, you've got 2 tutors, so please make sure you have the correct name, the correct tutor, you access that one, okay? Let's see, alright, so if in case you cannot find, right, there's too many stuff of e-learning, too many subjects, you can also click on the forum under my task. Okay, blah blah blah. Alright, so what happens, of course, you need to click on the forum to access it, and then you will see all these topics. So what is going to happen, you need to check which group you are in. Okay, so a class is very big, a whole class in the forum, it will be madness. So we have divided you into groups, and how do you check? There will be one topic called groupings. Okay, so obviously you just go in and look for your name to figure out whether you are group 1, group 2, etc. Okay, so let's say you're under group 1, then you just need to click on that particular group to go into the page. Okay, so what happens when you click on that, then you will see the question that you are supposed to do. This question is in a PDF format. Okay, also there will be certain rules and regulations with regards to the forum usage, which is written down here. Alright, blah blah blah. Okay, so what happens is there will be a question and there will be something for you all to discuss. So what do? You need to click on add reply to start off the new comment. Let's say you are the earliest one who started. So you are the first one to post. Click on add reply. So you say, okay, I think for question 1, the answer is blah 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 blah. Then you write down. Okay, so if let's say you are the second or third one posting, your friend say, I think the compound is ethanoic acid. Then you dispute, you think it's propanoic acid. So what do? Let's say your friend over here posted ethanoic acid. So you can click on the reply on the message itself. Okay, either with or without code, it doesn't make a difference. Okay, then you can dispute, you say, no lah, it cannot be ethanoic acid, there are 3 carbons, hello. Okay, so the instructions is that we need you to make constructive comments. Okay, constructive doesn't mean I agree with Samuel. Okay, that is not constructive. Or I disagree, full stop. Okay, so try to put some explanation. I think it's ethanoic acid because the CN undergo hydrolysis, something like that. Okay, so try to make some chemistry sense as you write, not just I agree, I disagree, this is wrong, this sucks, whatever. Okay, the teachers have the power to delete your comments, and of course we will know who posted what. So if you write all sorts of nonsense, we will see it. Okay, so preferably try to do it by 6 p.m. Don't do last minute work. Okay, if you are referring to lecture notes or what, you can include the reference. If you have online references, you can also include the links. Okay, nothing. here. Okay, over here. So what happens is that some of the questions, they may be a little bit of a challenging nature. So your tutor or via your cam rep may tell you to go to the forum at a specific time. Because if not, it's not much of a forum. I come in 10 a.m., nobody. Then after that, my friend come in 11 a.m., reply me. It's not much of a discussion. So either your cam tutor or your cam rep may set a time to say everybody must access at example 10 a.m. Okay, so please adhere to that. If they say 10 a.m., then try lah. Okay? So you got to check with them. Are there any questions? It should be quite clear cut. Okay, we'll post this on Ask and Learn chemistry page in case you forgot. Nothing else, right, tutors? Alright, so that's all. You're dismissed.